Welcome to the first ever episode of the all-new show, Tech Inspection. I am your host, Brian Petty, along with my friend Brian Wagner. And Wagner, go ahead and give the viewers your background and
Yeah,
talk a little bit.
I'm kind of, people probably see me a lot around more behind the camera instead of in front of the camera per se, being at the track covering races for many years for Dragzine, everything from NHRA, outlaw radial stuff, World Cup, no prep. So, I've crewed on cars. Everyone see me behind a car, crewing on a car, turning wrenches, driving the golf cart, doing a little bit of everything. So it's going to be a lot of fun kind of being on the show to talk about tech and for me to learn a lot because I have your everyman level of knowledge. So I'm going to, kind of really talk to our guests and kind of push them to teach us. That's what the show's all about, is educating on tech. So I'm pumped. Let's learn some stuff.
The main focus of this show is to teach you guys a lot of ins and outs of some really technical subjects inside the world of drag racing. To give you an example, on this very first episode, we're going to be talking about turbocharger technology, specifically in the X275 racing class. And all the other subjects that we're going to cover in the weeks ahead could range anything from, how a shock works and how it's built and the technology behind that to, oh, hey, let's talk about four-link, drag racing suspension. Like, what is it all about? How do you guys set it up? Why is it so important? And everything in between. It's a very technical-based show with possibly a little bit of drama sprinkled, here and there as it's needed. So even if you're not a huge racer, you're not at the track every single week, and you just have a street car you want to make a little bit faster, make sure to stay tuned, because even though we have these big names with these massive brains on the show, everything trickles down. So if you have a car with a little bit of nitrous and you want to, know how to make it a little bit faster, we're going to have nitrous guys on. We're going to have turbocharger guys on. We're going to have supercharger guys on, and everything they say can help you.
Well, one of the things I want to do on this show is have some fun, because we're going to get into some really kind of crazy topics. So, we spend a lot of time on the web, and I like to dig around. I'm a swap freak. I love seeing crazy swaps, engine swaps, new tech, all kinds of fun stuff. But on this week's fun segment, we're looking at kind of weird swap I found. And I'm going to throw this to Petty to get his take on it. So, we can get his reaction. And what I found was this dude that took a VW Beetle, and we've seen these swap before with V8s and LSs, twin turbos, anything under the sun. This dude has stuffed a new Coyote engine in the front of a VW Bug. I haven't seen this before, Petty. What do you think of this madness?
I don't know, man. The Coyote, I'm thinking from a dimensional standpoint, that is a very large engine, and those cars are extremely small. I've never been a real big fan of the Volkswagen Bugs, but I definitely have seen some really cool things that people do with them. And this one kind of takes the cake. It is extremely cool. I'm just really curious how they got the dang thing to fit.
I've got so many questions on how they made this happen, and it looks like it's rolling on some racing tires too. And I mean, it looks like it's all business. So, there's a lot to drink in here, and that's why I love. When I saw this, I was like, all right, I got to bring this on the show just because there's a lot of tech involved with cramming that engine in there. So that's I dig it. I just wanted to bring that up here for our first fun segment to see what you thought of it.
Also, I brought something on as well. This is something that's really been interesting, and I just got the specs on it yesterday. So the C8 is something that's been in the news like crazy. Lots of people are buying them. They're loving them. They're going 11 stock. They're hitting them with a 2-shot of nitrous and going 10s or whatever. And that's super impressive. The car is very cool, and I love it a lot. But the guys over at Vengeance, they had a customer that bought a brand new C8 Corvette, right? This thing's brand spanking new. When it came into the shop, it had 7 miles on it. So I'm thinking they bought it at the dealership, drove it straight to Vengeance, and just said, all right, let's just go. And rather than doing maybe we'll do nitrous, maybe we'll do a little turbocharger. Oh no, these guys just threw everything out the window, and they are putting in a 427 cubic inch,
Ooh.
all billet engine. Ooh. Built by LME. and to top that all off, that's not the end of it. I mean, it's obviously got all the gangster stuff on the inside: billet aluminum rods, billet crankshaft, custom pistons, keyed lifters, a bunch of different stuff. 8-stage dry sump. 4 or 5 is a lot. That's 8. And on top of all of that, they are putting twin 94 millimeter turbochargers on this thing, and they're shooting for 3,000 plus horsepower.
the first thought that pops into my mind is a cruel prank to do is just drive to the GM dealership and be like, man, this thing's got a funny miss. Is this covered under warranty? And watch that tech's head explode when they pop that back hatch, because there's not a lot of room for arts and crafts inside there. So taking and cramming all that in there, my interest is peaked. I want to see how they make this happen, because that's going to be a pretty gnarly car.
Oh, absolutely. Because I had just kind of hinted to a couple of my friends about it, and they're like, "Dude, how they haven't even unlocked the PCM or the computer in the car yet?" And it's like, yeah, I don't think these guys are really worried about that. They're basically buying this brand new killer car and just dismantling it and completely building it standalone. It's not going to have any of this stuff. It's going to have a fully
Oh,
sequential
wow.
transmission in it. So that just tells you how far these guys are going, and it's something really cool. I mean, you can see the engine; it's all billet intake manifold, billet valve covers, cylinder heads, block, everything on the internals is billet, and they're looking for some big power. So I thought that it was something kind of cool, to help warm up on the show, just beyond what I would
Yeah,
ever
and
expect.
we'll
So
just call this a fun segment. It sounds flight and fluffy and interesting, and we can roll with that. And the final thought on that C8 is, imagine the phone call to Bowling Green, to the C8 engineers, and they're going to be like, they did what? How? Why? All right, that sounds cool. And then they're just going to roll with it. So I'm all about it. I'll take one as soon as I win the lottery.
I think that we can, really dive right in and see exactly what our first guest has to say and, get his feedback for sure. Cause I'm kind of along the same lines as Wagner. I know enough to get myself in trouble. And so I think that we should rely on our guests and their expertise rather than my personal experience. What do you think
Yeah, I
about that,
totally
Wagner?
agree. I think with the guests we have queued up today, Roger Conley, John Sears, and Tristan Kemp from Precision, that we're gonna get some schooling today on all things that go spinny whirly boosty.
All right, so we're just going to dive right into it. We have Roger Conley on the line, and he has a extensive background in drag racing as well as turbo expertise. So, Roger, welcome onto the show. Just go ahead and introduce yourself and give the viewers a little bit of your background and why you're here.
All right, thanks, guys. Right now, I'm currently the National Tech Director for the NMCA and the NMRA. A little background on myself: worked for Precision Turbo for a few years. Worked for Race Pack Data Systems for a few years. I've worked for the likes of John Force Racing, Brad Urban's Carburetor Shop. I've had a pretty extensive background. Worked for Pro Mod Racer Bill Coolman, first guy to ever go 200 miles an hour. So pretty diverse. Been around nitrous turbos, blowers, nitro, gas, alcohol, you name it.
A very wide range, to say the least. So, obviously, we've already given you a little bit of a heads up of what we're talking about, and let's just dive in. Let's talk about turbochargers, X275, class requirements, and get your take and get your expertise on, how that all works with you since you have your history with Precision. Just give us a little bit of a rundown on that.
So for like the X275 class, we currently will measure the inducer and exducer of the compressor and the turbine wheel. And what that is the inducer is the leading edge of the compressor wheel. It'd be the smallest part of where the actual, for lack of a better term, we'll call them fins are. And the exducer is the largest part of the wheel. So we have some tools that we have had made that we actually put over both of those parts of the wheel. A go, no go gauge is what we call it. So if it fits, you're good to go. If it doesn't fit, obviously your turbo is not legal.
And kind of going off of that, when at the Sweet 16 event, when they were last year, they were putting up, 50,000 to win for X275. You guys, you gave them the white glove level of tech. What was that like? And, was there anything interesting you guys found when you started teching some of these X cars? Because these guys can be kind of squirrely with what they try to do.
Yeah, there's a couple things that come to mind, but the one that stands out the most was the one import car that was there. His exducer on his compressor wheel was just a few thousandths too large, and the ring wouldn't go over it. And so he elected to spin the turbo with an air impact gun and hold a file against the fins and actually take the material off till the ring would go over it.
On race day, you know, you got to do what you got to do, and that's that's a little out there. But hey, to make the rules, to make the car legal, you got to do what you got to do.
So, looking at that, Roger, why is it important in X275 to really kind of watch those two, the inducer and exducer like that? How can teams play with those to, get more power?
Well, originally, when turbos first started getting measured, I can't say I could speak for X exactly, but for most part, they were just measuring the inducer. So they were just measuring the smaller side. So then what the people started doing, the turbo manufacturers started making the exducer larger and larger and larger, which allows the turbo to process more air while it's coming in. So to clamp down on that, then an exducer limitation was put into place. And then, as I said, the same thing was done on the turbine side of the turbo. You're referring to Sweet 16. We pulled every single, actually every power out of our part, but we took every turbocharger apart and we measured the inducer and exducer of the compressor and the turbine wheel. We measured the map groove where the anti-surge groove is, and now we're even measuring the diameter of the hub on the exducer because they were machining those down to process more air. And so we cut back on that because if you take too much material off, the turbine wheel will actually fail. It'll come apart at high speed.
So I had a question kind of to come back a little bit because we're talking about inducers, exducers, that kind of a thing. And why is it pretty much industry standard? Like, I want to explain that, why it's industry standard for almost every sanctioning body to measure the inducer of the turbo and why that's so important. I want to get your take on that.
Well, the inducer is what we call the turbo, right, for a size. So if it's an 88 millimeter turbocharger, it's got an 88 millimeter inducer. So that dictates where we're at. Like if you got an 85, if you're going to run the lighter weight, the smaller turbo, we're going to measure it there. It's got to be an 85, and so on and so forth. And 94 is a 94, and we go from there.
And how does the exducer kind of come in line? Because I know that you're talking about people are getting bigger and bigger, and yet most sanctioning bodies still measure like the inducer as the main thing and then the exducer as like the secondary thing. Maybe talk to me about the differences between those two and how they relate to power and flow and efficiency of a turbocharger.
The easiest way to explain it is if you were to take either wheel and you were to envision it as a paddle wheel on the back of a paddle boat. So the larger you make that paddle, as long as you can turn it, the more it's going to move the boat because it's going to push more water. So it's just about volume, plain and simple. And the other thing to remember is when you're looking at rules and measuring things on the exhaust wheel side, the inducer and exducer are the opposite. The inducer of the turbine wheel is the larger part of it, and the exducer is the smaller part of it.
And that's something I feel like a lot of people get confused because, you talk about the inducer and exducer on the compressor, but like you said, on the exhaust, it's completely flipped. The smaller part, is not the inducer, and the bigger part is not the exducer. So that's something to definitely bring up.
Yeah, it's real easy to remember. It's just where the air comes in is the inducer, and where it exits is the exducer.
Kind of switching gears here a little bit, Roger, something that, I was trying to coach myself up on, turbo talk. And one of the things you hear a lot about is, billet versus cast wheels, stuff like that. With these wheels, is the billet wheel more of something where you can bring it to production quicker? Is it a strength thing, or is it something where you guys can really, where a company can really take a turbo wheel and kind of make it a boutique item?
So the billet versus cast deal, basically how that works, and I won't get too in depth, but so cast wheels came from the background of originally they were taking basically diesel truck turbochargers and just machining down a cast wheel to a size and bolting a turbo together, and that's how they were getting more performance out of turbochargers before they were making wheels. Having the billet wheel gives you the ability to model the wheel and increase the aerodynamic efficiency in the range that it's going to operate on in a race car.
Yeah, that's what I was kind of wondering with that, where you can go through and make it, gives you an opportunity to really kind of custom make it based on what you need it to do and how you need to make it happen. And that kind of is pushed a lot of the development with these turbos, I think, in these different classes, especially in X, where you have such a very, very tight rule package for the turbos, match the engine combinations and the weight. You have to start finding a new area to kind of gain that efficiency, right?
Absolutely. Yeah. So it came in the form originally, like you said, of compressor wheels. Then it's transferred to exhaust wheels, and kind of went back a little bit to compressor wheels because they started whittling the hubs down on the compressor wheels also. So they're bouncing back and forth. But as we continue to tighten the rule setup, they're going to run out of places, hopefully.
Racers are very crafty groups of individuals that will find funny ways to circumvent rules. And, kind of over the years, how has these turbos in these classes kind of changed? What has been the progression with them on how the development's changed in, something like X, where the turbos have been changed to improve performances? What have you guys, what was attacked?
I think from the inception of X, there's the billet wheels have always been there, so that hasn't really progressed. Other than, again, some aerodynamic changes have been made from some of the companies. The newest thing is the compressor cover. Machining it in a way to let more air come into the compressor wheel through what they call the map groove, and kind of read the rules and kind of were scrutinizing the rules that way. We had a new compressor cover come out this year that just went out there, and on 3 cars that I witnessed at my event, they made more boost just back to back, taking off the old turbo and putting the new one on. I actually saw the data with my own eyes, and a lot more boost.
So I want to dive in a little bit on that and talk about the tech and the importance of the map grooves, the ported and anti-surge housings, and how that went from being like we want to keep the surge down to it's a massive performance advantage. And I want to get your take on it, because I think all of us know exactly what turbo you're talking about, but let's talk about the tech and the really specific stuff on the ported housings, as well as the map grooves being changed, what they were originally meant to do and what they're doing now.
Yeah, and I think getting, we're getting in depth to engineering level stuff that I'm not as familiar with, but to keep it into layman's terms, they're taking the groove that was used to instead of putting the compressor into surge. So if there was no map groove at all, if it was just a solid cover, at some point that compressor gets into surge and it side loads the turbine real bad, and it'll knock the thrust out of it. So there's this groove in there, anti-surge groove, to keep the air recirculating at that RPM. Well, what they've done is they've looked at the rule, and they got the same, 250 thousandths or whatever the measurement we give them is, but they've opened it up on the other side to allow more air to come in and be introduced into the compressor wheel. So now you're not restricted by just an 88 millimeter opening, or 88.9 or whatever it measures to. They're getting more air in that way, which in an effort to crack down on that for the rule set I'm using with our X style class and NMRA, is I just passed a rule recently that says all turbo covers will have to be approved by NMRA tech, even if they've been used in competition before.
And that's a big deal for, multiple different reasons. But my actually closing question for you was, with everything going on with the way rules are being bent and changed, is something in the future a possibility of like having a spec turbo for a class? I mean, Pro Chargers, they don't have the modular capabilities of turbochargers. You know what I mean? Like, you can have an 88 millimeter turbo, ship it off, and they can make it a 94. You can have your 98 shipped off and have it be an 85. And whereas like centrifugal superchargers, they don't have that fluidity to them. And so is something in the future we could see being just a spec turbo for this class. That's it. You run this turbo and that's it. Is that a possibility, or what do you think?
That is a possibility, and you may remember. I don't know if you remember when Donald Long came out with a little video talking about where we were going to actually fly turbos in to the race and have boxes sitting there of the spec turbo, and they were going to have to bolt it on. And that was kind of the inception of, honestly, DXP Street. Then it went to the nitrous thing, but we talked about that. And the answer to answer your question, yes, that's a strong possibility in the future. My preference would be to come up with a program for the manufacturers where they would send me a turbocharger that has a fixed serial number to it, or a fixed serial number and part number and a drawing. And I would make sure it measures to the drawing. I would keep the drawing, and then there would be an approved part number list. And I would do that for any manufacturer that wanted to jump in. I wouldn't choose favorites. It could be a Bullseye. It could be forced inductions, Garrett, Precision. They could all come in and play. There's no problem with that, But one thing I do want to say, though, before we get off of this, is what a lot of people fail to understand about the performance on these limited classes like this is that the same combination doesn't have as much of an advantage in very different weather conditions. And what I mean by that is everybody automatically, when a car goes fast in mine shaft conditions, they automatically want to say, ban that dude, hang weight on him, do this, do that. Okay, let's talk about that. Come summertime, when the air is thick and it's full of water and it's hot and the track's not very manageable, that combination may not be the killer combination anymore. That Manny Bajinga combination at Joliet, Route 66, J.D. Campbell come up with a nitrous car. And like I said, track conditions aren't as good as they were. We got crappy air, and all of a sudden, what just happened? This guy's outrunning that guy. And it's like, this was the baddest combo in the world. We need to hang weight on it. We need to outlaw it. But that's something that gets lost, that people want to make rules based around the fastest runs on the planet at the best racetracks. And that's not fair when you have a series that goes around and races for points and goes to different geographical locations for different parts of the year.
I think that's probably the best way we could wrap this up, because that covers everything that we've, with these turbos. And then that ending right there, Roger, I think sums up exactly when you see people complaining about rules in these classes. That sums it up right there perfectly. I got no other questions after that. Do you, Petty?
I am totally good. That was a great way to kind of dovetail that into a nice ending. So, Roger, just want to thank you for coming onto the show. Your insight, your expertise, and your background is legendary, and we're really happy that you were able to come on today. So, again, thank you.
Thanks for having me, guys.
All right, so that was really cool having Roger on. I really liked getting his insight and the different things that he talked about. We covered a fairly wide range of stuff, but we kept it pretty tight and concise. And I don't know, just talking about the map grooves and the fact that he brought up the turbo, which shall remain unnamed for now, and just the different rules, specs. And I really, really liked how he brought up hey, maybe this combo that's setting this record over here, in perfect conditions on the perfect track is amazing, but then take it into summer, you got density altitude of 5,000 feet. That combo might not be the way to go compared to others. What do you think about that, Wagner?
Oh, yeah. I totally agree that, the rule side of things, the way he broke down why exducers and inducers are looked at, especially in X275 racing, and how you have to really kind of keep a very tight rein on this. And a lot of people, I think the fans don't realize what goes into crafting these rules. It's not easy, because these turbos are amazing pieces of technology. And then you get it in the hands of racers, and you get it in the hands of smart people like John Clevitis and so on, that they'll go through and start finding ways to make these turbos even better. If you don't put some sort of handcuffs on these boys, it makes it pretty insane quick. And then to the point about the rules package for different times of year, it's like a bell curve. You can't set the rules based on what happened in the fall at SGMP. Like you said, when you go to some place like Joliet in July and the air's garbage, and then you go back to the shakedown, you have to kind of do something in the middle, because in class racing, someone's always going to be faster, but you can't give them carte blanche to completely run away with the class.
All right, so I think that wraps that up pretty well, and it brings a perfect segue into our next guest. John Sears is on with us, and I think that we can just keep talking about the rules, X275, the turbochargers. And John, welcome. Thank you so much for being on the show. We really appreciate it.
I appreciate you guys having me. Thank you.
What got you into doing rules for X275 and Ultra Street and all these other heads-up drag radial classes? Like, what got you into that, and then also like what's your background on that as well?
Well, I kind of started when I lived down in Florida, working with those guys to try to get drag radial started at the World Street Nationals with Troy Perez and Big Daddy Dwayne Guthridge and Chris Little and a bunch of other guys that were running drag radial back in the day, either the NMCA or NMRA or NSCA. And we wanted to get it instituted there. So often got online and just started poking at guys all over the place, letting them know that, hey, we'd love to get, a bunch of cars down there. And it kind of moved on from there and did some things after I got back from a couple of tours in the desert with a Immokalee dragway down in South Florida, where we had stock suspension shootouts and helped with the rules down there. We tried to keep it simple, far different than what X275 and Ultra and the other classes have become. We had a 10 rule maximum. We didn't want any more than 10 rules. And it was a stock suspension, drag radial, 28 by 10 class down there. We did that for a number of years, and then it kind of got out of hand for some guys, as all this stuff does. So we brought along the 650 index, and that you had to be on a radial tire, no back half cars, nothing like that. And that kind of morphed into Florida Real Street. And Florida Real Street was sort of the precursor to what we're dealing with in Ultra Street today. And actually those rules were grabbed by Charlie Taylor and moved into 8.5 racing, which we've worked with Charlie now to sort of bring 8.5 racing back with almost that same rule set. So kind of all over the place. X came about because we wanted to give nitrous small block cars a place to race. Drag radial was running way fast in the quarter mile at the time. We still weren't running eighth mile, and nitrous small block cars were getting left behind. So we dropped the tire size down to 275 and had nitrous small block cars out there. And, that's just morphed into in the madness that it is today.
Kind of going off the madness side of things, and I think you've set the table really well for the question I'm going to ask is we're looking at the turbo side of things. We're talking turbo today, and you have this, what I call the torture table of tools for these racers. Why is that? Why are those tools so important when you're looking at turbos in X275?
Well, the way we've got the rules written nowadays are, I'm going to say they're very narrow in scope, and they're far more wordy than most organizations have out there. So in order to enforce those rules and make sure that the turbos that are coming through tech are in compliance with those rules, we have to measure them in multiple locations, and it takes multiple tools for multiple size turbochargers for us to do our job properly.
And so I had a question about just your rules, because right now you do write a lot of the rules for like X275 and Ultra Street, correct?
Yes, and limited 235 as well.
So yeah, and today we're specifically talking about X275, but honestly, Ultra Street and these other classes, honestly, they do have restrictions and very narrow rule sets anyway. But talk to me about X275, kind of where the rules used to be and where they've progressed over, let's just say, the last 5 years, and how turbo technology has really, really ramped up. I mean, 5 years ago, if you would have told me, hey, X is going to be in the 420s, I would have been like, no, you're high. No, that's not possible. Right. But it is happening.
I would have told you the same thing.
Right?
I would have told you the same thing.
It's crazy. Yeah. So I just want to get your background and kind of help explain that progression, and then how in the rules side of it you guys try and temper things, keep it as safe as possible, but at the same time giving the racers the ability to go fast.
Right. So I one of the big things is the 88 millimeter turbo has always been like the basis for the rule set on the turbocharger side of the house, and that basic 88 millimeter inducer, which is the leading edge where the air comes into the turbocharger, has been essentially the same since the beginning. We've also, worked with manufacturers in development on the 85 millimeter stuff that gets a little bit of a weight break in regards to the 88 stuff. And what we're seeing is turbocharger manufacturers and folks out there, we give them this set of rules and we give them the box to build in, and these guys are building better components inside the parameters that we give them, sort of inside that box that we're making them adhere to. And then you have to look at the other things, the introduction of the Mickey Thompson Pro 275 tire. You look at the various gear sets that are now available for transmissions. You look at converter technology, everything, with the shock sensors. People are able to gather more data on their particular combo. And it used to be where turbocharged cars would not 60 foot. And now that you have the advent of dump valves and other things like that, it allows the turbocharger to spool quicker than it has in the past, which has allowed them to 60 foot better, 330 better, and then of course 660 better. So it's sort of a comprehensive thing where you're looking at the entire package as being far more efficient than it had been in the past. But turbochargers have made some great strides, particularly in the past couple of years, with what they're doing with the blades themselves, the way they're tapering the blades out towards the exducer, which is the large side of the compressor housing, and a bunch of different things like that. They've even gone so far as to modifying the surge gap in the cover, and allowing some different things there. So we've had to sort of limit what they're doing there, which is pretty unique.
Kind of going off of that, I've got an interesting question here. There's different size turbos allowed in X275, and the rule book is 1.5 miles thick. Kind of looking at these different turbos, the weight breaks, the engine combinations, and just how all of that kind of works together. When you pair that with the turbos, what's some of the turbo combinations you think are the more efficient and better ones within X275 with the engine, big block, small block, stuff like that?
Well, we're limited to small block combinations with turbochargers. There are no big blocks with superchargers or turbochargers allowed in the class. So you sort of get down to an efficiency range and a back pressure range with the particular turbochargers and the exhaust housings. So with those in mind, something around 420 inches is about ideal, and that allows a high level of efficiency, and then of course the exhaust housing size comes into play when you talk about the back pressure, which is the amount of back pressure the turbocharger has going down the track. Some of the stuff in Ultra is 2-to-1 pressure. So I think what you'll see is X275 cars probably in the low 30-pound range for boost, probably not much more than 35 or 36 on some of the smaller cubic inch combinations, because as you go down in cubic inch, you are able to increase boost because there's a restriction, so to speak, because of the size of the engine or the size of the intake runners.
And so, something else I wanted to talk about there, it's been brought up a little bit, and we don't need to talk brands, we don't need to talk specifically, but there's been a turbo kind of brought up that came in and started making some really fast passes. And what did you see as far as being the rules guy, and how did that turbo, like, how was it able to really go above and beyond what we already had? And then what did you have to do, and how did you have to look at it as far as a rules perspective to be like, hey, this might not, this is in the gray area, or maybe it's way off and it's not even in the gray area. It's just not even allowed at all. Talk to me about that process, about when that happened at the race.
Right. So we saw sort of the tip of the iceberg when we were at PRI with the compressor housing. And we had been noting the previous year some modifications that were being done to compressor housings and things of that nature there. So as we wrote the rules for 2020, we put a couple of things in place that we thought covered most of the areas that these guys would be pushing the envelope on. And one of those areas was opening the area leading to the surge slot on the backside of the compressor housing. And when you open that up, it allows not only air out, but it allows air in. And the amount of air coming in allowed some additional horsepower to be made, which was reflected in ET and mile an hour. And we felt that it was a little out of the realm for the rules and the spirit of the rules. So we worked with the manufacturer to come up with a plan to sort of rein that back in and let other folks know that, these types of mods were not going to be accepted in the future. So we sort of made a clear decision on that. And the folks that we've worked with have been more than happy to work with us on this, because they don't want to see things get out of hand and car counts dwindle and things of that nature there. Because once somebody goes out and runs fast, as you guys know, it's like a out of control forest fire on the internet. Everybody has their thoughts and ideas of what's making people fast. And oftentimes some racers are smarter than others, where they will sandbag a little, and some just don't give a dang, and they'll go out there and run their combination fully. And that although I do appreciate that, because that gives me a chance to level the playing field a little bit better, it does make my life a little bit difficult at times.
And kind of going off of that, John, you can't legislate prosperity in rules in racing or in life. You got to be able to work for it.
Nope.
And, some of these teams, with these turbos, they might be first stepping them into X275 or something like that, looking at the rules in this turbo technology. You're the grand wizard of all X275 and boost. What, when messing with these turbos, what advice would you have for people that are stepping up to a boosted turbo combination in X275 to really hit the ground, running? What do they need to look at? What do they need to attack?
The overall efficiency of the car and the combination. So whether it be an 80 millimeter, an 85 or an 88 millimeter, whether or not you're running on gas or you're running on M1, you need to look at the overall efficiency of the combo, and not be afraid to color outside the line. Sometimes a lot of guys, rather than utilize what they know and what they've seen, they'll just cookie cutter somebody else's combo. And X has always been sort of that pushing the envelope class. My job is to write rules to keep it from getting completely out of hand. But we do need to have progress, and we do need to have the ability to work with manufacturers on introducing new parts and new components, not only in X275, but other heads-up classes as well. Otherwise, the industry dies, and there's really really tough times for everybody.
I think you've given a lot of really good information for sure. There's, obviously a wide range of rules and specs on turbos. And I think that you really clarified a lot of that and gave kind of the rules side of it. I don't have any more questions. Wagner, did you have anything else for John?
Oh, we could go through and talk to John for hours about this, but I think with what we're trying to accomplish here, I think this definitely is going to give a lot of viewers, a lot more insight into what goes into what John does, why he does it, and why, trying to tame the turbo monster is not an easy task.
No, not by any stretch of the imagination. And I really, have looked at how our rules are written and how we can improve upon them every year. And I've worked with Roger and Donald Long and other folks. I bounce ideas off of them. Lonnie Grimm, several other folks. We asked the questions and we dig in deep and we try to figure out what's going on and how we can improve things and how we can make things better. But nobody is infallible. And racers are very savvy. Their tuners are very savvy. And they will go out and continue to push forward to go as fast as they can under a given rule set. And I preface, my discussions with many racers, that listen, if you fall outside of what we consider, a prudent ET for the success of the class, you will get weight. And we will utilize weight to bring the combo back into, the realm of competitiveness with the other combos that are out there. We've reached a point now where we can't continue taking weight off other combinations to make them competitive. Some have just reached the not going to say the end, but they are nearing the end of where they can go and how efficient they can be and how fast they can go. They'll continue to chip away at it, but turbo technology allows steps rather than just tiny little crawling motions. These guys are leaps and bounds where the rest of these guys are taking smaller steps forward. They're moving and they're improving, but the turbo guys and turbo technology just has the ability to move at a faster pace.
Okay. Well, John, like I said, I can't thank you enough for coming on. You've given us a lot to think about, a lot to talk about. Diving in was really cool. Really happy to have you on the show. And I think that's all we have for you. So like I said, just thanks again. And we really appreciate it.
All right,
Thanks,
guys.
John.
Thank you much. And take care. Appreciate you having me.
Thanks, John. So that was really cool having John on because he is like a really, really big guy for rules. He's got a lot of background. He's got a lot of knowledge, and being able to pick his brain and seeing I love that you brought up the tools, the torture tools that he's got for all the turbo guys, all the, precise measurements and that kind of thing. And then also just getting his take on we have to restrict and we have to make sure that things are in line, but at the same time, we don't want to completely block the entire class and slow everybody down and make nobody want to race. There has to be a progression, and I like that balance.
Yeah, I mean, John has a very unenviable job trying to take care of that class, especially with the turbos, because racers are going to find different ways to improve on a great product already. And I think that's going to be interesting when we bring Tristan on from Precision to kind of get the manufacturer's take on that as well, because they're trying to make everybody faster, and it really kind of puts them in a dichotomy of a strange situation. When you hear what Roger had to say, you talk with John, and you start seeing this picture develop about turbos, and specifically in this class, and just how important efficiency is and what they do. And it's bigger isn't always better, especially in this class, just figuring out how to make the stuff work. So I mean, it's pretty wild for sure. And we could do an entire 2-hour long show with John and still not cover everything.
I could go all night talking to any of our guests for sure, but I'm really glad you brought up Tristan because Tristan is our next guest that we're going to have on here very, very shortly. And he, has a lot of precision turbo background. He works for them, and he also ran their turbos before he worked for them. And so it's going to be a really cool, interesting way to talk about turbos from another, like from a manufacturer's perspective. And I think that he's queued up. So let's just dive right in and get him on the line and start talking to him. I think that's going to be great.
Speak of the devil.
And there he is. There he is. Tristan, how are you,
doing
man?
all right. How you guys doing?
Good. Good. So we just got off the line with John Sears, as well as our friend Roger Conley. And so now this is going to be, it's just going to dovetail beautifully, because now we got somebody on the manufacturing side to talk about turbos and tech and, and just dive right in. So first, Tristan, let's just talk about your background, your history with precision, and just overall performance, and maybe any achievements that you would like to talk about.
Yeah, so I guess we'll start off. So I've been with Precision now for a couple of years. Started in 2015, physically started at the facility. Prior to that, I had worked a few events with them and stuff, and I've been using the products since about 2006. So kind of had a background with them prior to, and then of course just over the years that led into actually coming to work for the company. And it's one thing led to another, and here I am doing pretty much like technical and sales now. So
perfect. So I know we talked a little bit before. Basically today we're talking about turbochargers, and more specifically X275 class, requirements, restrictions, the different things on that, and then also what Precision, what you guys have done to progress the technology in turbochargers over the last 5 to 10 years. Because I know I already said it, and John 100% agreed with me. I was like, if you would have told me 5 years ago that X275 would be like the top 5-6 qualifiers would be going 420s, I would have told you that you're 100% out of line. That's insane. And now they're going faster than RVW was, years ago as well. And it's been crazy.
Yeah, I mean, it's definitely, you look at like where things have come, where they're progressing to, and it's definitely, I think at this point, even like John Sears will tell you, it's gotten to a point where we've got to kind of reel it in a little bit to try to keep everybody, parity and keep the class together. So.
Yeah, no, he actually did bring that up. He's like, man, it's tough because we got to restrict it, in some instances, but at the same time, there has to be a natural progression of the class. So yeah, you're dead on with that. But Wagner, did you have any questions that you wanted to kind of start off on the technical side, turbocharger side?
So many questions. I have a very, I guess, would you call it with turbos, like the everyman kind of functional knowledge with stuff like this, like just enough to be dangerous. And it's always awesome to have an opportunity like this, especially when we're talking X, because I've crewed on an X275 car, and I understand all of what they're talking about, efficiency and making everything work together. And the one thing that I've saw come up in my research that I wanted to kind of, maybe talk about, I keep hearing Petty and, talk with the guest, is talking about, the surge in the map slots and, kind of what's going on with that, and that might be something that our viewers don't know about, kind of give us the X275 / Turbo 101 about things like that.
Yeah, so obviously there's been a little bit of controversy, and over the years, I'll say this, it's been a kind of an ongoing thing throughout turbochargers in general. So whether that's drag racing, whether it's no prep, X275, you name it, even in tractor pulling, there's always been kind of this this stigma around, what you can and can't do. And so map grooves, and the ported shroud plays a big role in that. So depending on how that is done, if it's done from, we'll say, an efficiency standpoint, that map groove or ported shroud, it's all kind of one component in the compressor cover. It allows you to widen the actual map, so to speak. So the turbo will go into surge later versus sooner with the map groove and the ported shroud, which helps obviously with efficiency. When we get on the racing side of things, though, you can manipulate that groove and that shroud to allow the entrance of additional air, which effectively makes it somewhat of a larger turbocharger, bypassing the standard inlet. And I think that's where the rules come to play. You really got to make rules that limit the size of that groove and the angle that it comes in at. I know you can look back to I think 2011. We released a large frame 88 for X275. That turbo came out on the car called Vader. Pete Harrell was driving it back then. And when that car came out, there was a whole bunch of controversy, especially from the nitrous guys that did not understand what a ported shroud was. They saw all the holes around the inlet, and they immediately said, that turbo's sucking in a ton of air in comparison to a standard, turbocharger. In reality, it wasn't. It was just a ported shroud that went down to the map groove, and it was there to serve the purpose of, being an anti, surge. So rules came into place. They had to make a cover that went over top of it, and there was a 250 groove rule that went into effect, and honestly, it didn't slow it down because the turbo wasn't really making additional power from that surge to begin with. And as we've progressed on over the years, I think that's basically gone, we'll say, a little overboard, where people have kind of used that to their advantage to trick out the compressor cover, knowing that they can open that groove up bigger, knowing they can bevel the cut, knowing they can introduce more air to secondary veins. And, it's progressed along where I think we're now at the point where we've seen, if we leave the rules open to interpretation, somebody's going to take advantage of that. And it's going to take the class, kind of to a place we don't want it to go. So it's just one of those things where reeling it in, putting rules in place on map groove height, width, and in some classes they've actually done away with the map groove and the ported shroud altogether and just gone straight to a smooth bore cover.
So now I think you kind of gave a nice little, transition into it. You talked about map grooves, anti-surge housings, ported housings. Let's talk about precision specifically and give you that opportunity to kind of talk about like where precision was, let's just say 5 years ago to now, and what components on the inside of the turbocharger you've changed, like the weight of the turbine wheel or the fin angle on the compressor wheel, the difference between cast and billet compressor wheels when it comes to performance and class specs and weights. And I'd really like to get your opinion and your feedback on those things, on those really technical things.
Yeah, so I guess the best way to start that off with would be to look at like cast versus billet wheels. So traditionally, turbochargers back in the day, they always had a cast wheel. Those wheels were made by manufacturers, and they may have been made for different applications, tractors, trucks, different things. And those wheels were then used to manufacture turbos to use in the performance market. So we had kind of a limited amount of sizes we could use. We had a limited aerodynamic profile, if you will, as well as the cast wheel does tend to yield when the turbo gets surged, repeatedly. The cast is a little weaker and it can come apart. So the move was to go to billet. And a lot of people think billet has a huge advantage over cast from a performance standpoint. And it's kind of a double-edged thing there. It is, it does have a performance advantage because we can make wheels any size that we want. We could rapidly make them. You can, cut a new wheel in a day versus with the cast, you have to go through that whole mold and tooling process. It's very costly, and you're not going to make new technology, new wheels, new aerodynamic profiles, as regularly as you would be able to with the billet wheel. Also going to like precision, we use a 2618 forged wheel. So we actually start off with a forged ingot that's then CNC machined out. So, you look at the strength of it, we have considerably more strength over a cast wheel. And it allows us to do, a much more aggressive aerodynamic package We can also do much larger wheels, keeping the weight down, as well as a lot thinner blades and smaller hubs. So in the end, it all comes around to efficiency. We can basically make a much more efficient wheel that allows us to make significantly more horsepower and also keep that transient response, or most guys, they relate it to spool up.
So, kind of going off of that, I've got a question that kind of popped up in my mind here. Is that, you talked about the racers, making modifications to the turbos. Has that in X275 kind of led you guys to be, has that influenced what you guys do in your turbo technology? Kind of like, instead of you pushing it down to the consumer, have they done stuff where you guys are like, man, we got to, let's take this down the road from a manufacturing standpoint?
I'll say not really. As far as if you're referring to people modifying existing product and then us following down that path to put that into like a production piece, not really something that we've done. We've always tried to stay true to, like, we design a product for a particular market or particular application, and that's kind of the product we stick with. Especially when you're referring to X. With X275, we've always held by the standard of, we wanted to make a product that's competitive in the class, but we want to keep it within the rules. And not just in the rules, we want to keep it within the spirit of those rules. We don't really want to go into that gray area, just because, we don't want to go there. We don't want our customers running products that other people are going to point out and say, well, that's kind of cheated up. We want something that's 100% legal and to the class. And I'll say there's probably some things in the street car market that were heavily influenced from what some of the racers have done. It's definitely we've passed that technology down, to some of the street car stuff. We started off doing our V-band, stainless steel housings. That started off as NHRA Pro Mod for SFI. And that's now trickled down through all of our turbos. So even like some of our smallest turbos, we now offer that same style housing on. So, the technology kind of goes down, but we don't necessarily, like I said, we won't take something that somebody's done to a turbo necessarily and mimic that.
Yeah, I guess the way I was going with that question is more along the lines of how much of, kind of the R&D development has that gone back and forth between the company and the racers, because racers, they're awesome at breaking stuff, and they're also awesome at figuring out how to make stuff work and go faster. And if that was something where you guys were able to go, oh, well, that, that's interesting, and, kind of worked off of that and work with racers. I know some companies do that, but again, with, like to your point, with X being such a very rules heavy class, that you can walk that fine line of, you get into some weeds that you don't want to get into there, essentially.
Yeah, and I'll agree with that. So yeah, so as far as that goes, we have definitely had customers that have broken a lot of stuff over the years, and they send it in to us. We always look at it, evaluate it, see if there's something that we could make better, especially from a longevity standpoint. You want your product to be able to last race after race, as well as in the R&D side of it, we do work directly with racers. We do test our products, with racers, and we look at all that data that we get back, and analyze it and make sure what we're doing is more efficient, makes more power, and I'll say that the racers do play a big role in developing turbochargers, from that standpoint.
Okay, so I just had one more question. I think you've given a really good, explanation of map grooves and compressor housings. They work hand in hand, and how I loved how you brought up that, like, the aerodynamics and just the overall performance of, like, your race application turbochargers have trickled down into like the street applications, because I'm sure there's a lot of guys that'll watch this and they're never going to race an X275 car, but maybe they've got a twin turbo Camaro with 2 precision turbos, and they're like, man, like is this really the best? And it's like, it's probably like if you paid for it, it's probably the best, man. Like it all trickles down for sure. So I love that you brought that up. And to switch gears a little bit, so we've kind of tiptoed around it, and I know that this was something that could potentially come up, but I wanted to get your side of it from Precision on the turbo that's been breaking the internet and talking about, because like you said, Precision's always been that one that like let's just not venture into that gray area. Let's just keep it where it is. Let's follow the rules and the spirit of the rules, and then seeing what potentially other places did with their turbochargers. You just said, hey, you know what, let's give it a shot. And so I want to get your background and your feedback on that for sure, because it is something that is very, very hot topic right now.
Yeah, it was definitely a hot topic at the beginning of the year. So we set out last year, we decided we were going to build a turbocharger for X275, and we were going to pretty much pull the stops out. So we had kind of watched the progression of the class the last couple of years. Obviously, our turbo had kind of fallen back a little bit, and so it was time just to come out with something new and bring it to market. When we did that, we had gone to the rule makers, explained to them what we planned on doing. I personally was with John Sears and explained to him what we were going to do and showed it to him. And at the time, everybody said, okay, let's see what it does. Go ahead. So, we manufactured the unit, had some guys go out and test with it. Very promising results. Obviously, Manny Bajinga went out there and set the record with it. And we knew it had more in it at that point. So, it kind of, a lot of stuff happened. Some memes were made, Facebook. It definitely stirred up a lot of controversy. And, in the end, basically they wanted to, Sears wanted us to change the cover and go back to a more traditional cover, traditional ported shroud. And that's what we did. We designed a new cover based on, I'll say a standard ported shroud design. And we went out and testing with that cover, and results are good. And then unfortunately Corona happened. So we haven't really got to see what it's going to do in competition yet, but we feel really confident, moving forward, that it's still a solid turbocharger.
So, because we had John on earlier, and he did talk about that, like coming in and going to PRI, and he's like, when we were at PRI, we saw the compressor housing, right? Like just the compressor housing, and we're looking at it, we're thinking, okay, all right, like kind of like that thing, like let's just see where it goes, but and then it went very quickly past what I think he was expecting, and then it's like, all right, like let's maybe revisit this and talk about it. So
yeah, I mean, it definitely, we knew what it was capable of doing, and it was one of those that it depends on the racer. Obviously there's quite a few guys that had that turbocharger, and they all had the shot to really go after it. I think some racers played it a little smarter, and didn't show their hand, while other ones wanted to make a statement and went after it. So, and it pretty much it pretty much showed the potential, right out the gate. So yeah, it was my memory serves me correct, it was a 422 with a 109/60. So yeah, so. It definitely, and it was 100. It's been 173 mile an hour. So it definitely showed it had the power there.
It definitely made some steam. So Tristan, just want to thank you for your expertise and your coming onto the show. A lot of good information, a lot of good tech, which is what the show is all about. I don't have any more questions. Wagner, did you have anything else for Tristan?
No, I've learned a whole lot here, and I think our viewers are going to learn a lot too as well. So thanks for coming on.
Yeah, no problem, guys. Appreciate it, and look forward to maybe some more down the road.
That was Tristan, straight from Precision. A lot of really good information. I like that we were able to get his feedback and kind of Precision's A to B to C on that very controversial turbo without getting too much drama stirred up. But a very interesting take on all of that. Our other guests were really, solid on here as well. I learned a bunch, and I feel like I'm a turbo guy, but I definitely learned a bunch. I think we asked some really good questions, and they gave us a lot of good feedback. But Wagner, what were your thoughts?
I definitely, like I said, I know enough to be dangerous, and learning a lot of this through them and getting that functional knowledge is that there's definitely a lot to learn here, a lot to soak up, and I think viewers might even go back through and rewatch this a little bit to even broaden that knowledge a little bit more, and be inquisitive, and that's what the show's all about, is educating and piquing that interest. So hopefully people are going to go out and try to learn some more on their own now.
I could not agree with you more. I think that as this show kind of progresses, there's so many different subjects. It's funny because more than one person brought up turbochargers have come a long way, but engines, suspension, converters, all the tuning software, all these things have come a long way. And we focus on one subject, but at the same time, we also have to give the room for hey, there's a lot of things that are making cars faster. And each week, just make sure that all you viewers stay tuned. We're going to be diving into very specific tech topics for tech inspection every single week. We really appreciate you guys watching. Make sure to stay tuned. We're going to come up with new episodes every single week, have new guests on that are professionals in their field, and diving into all different kinds of, drag racing technologies and progression. So make sure to stay tuned. Wagner, thank you so much for coming on. I really appreciate having you here and your wealth of knowledge.
Thanks.
So
had a lot of fun, and put my own little note on there. I want to challenge our viewers to comment online and let us know what you want us to try to cover on tech inspection, because it's just as much what what our viewers want to see. What do you guys want to learn about? What can we pull from the depths of knowledge of these experts out there? Let us know, and we'll see if we can incorporate some of it in. Maybe we find out who guests on. We'll ask you to give us some questions for these guests. Let's make this fun and interactive for everybody.
Absolutely, I couldn't agree more. So I think that's a great ending statement. So again, thank you, Wagner, and thank all the viewers out there. Make sure to stay tuned, comment, and let us know, and we'll see you on the next Tech Inspection.